Good afternoon, everybody. Welcome to this webinar on the electric vehicle charging station. So we are expecting lots of people today. So we will wait for a little couple of minutes for everybody to join in. And meanwhile, we will, as usual, ask you to answer a couple of questions to help us direct the presentation. So what percentage of people are online right now, FX? We have maybe 1/3. 1/3? Okay, that's good. By the way, I still have with me my colleague and friend, François Xavier, who will be monitoring your questions, answering your questions if he can answer, if it's a personal question, and or relaying the questions to me so I can answer for everybody to participate and hear the answer. So thank you again and good morning, François Xavier.
Good morning, everyone. You probably saw that I started the poll. I see some results coming in. We have about 2/3 of the attendance that was there for a previous webinar.
Okay, perfect. So this will help us. I will then go quicker over the standard stuff at the beginning, presenting the company and all that, because of course I don't want to bore you with that, but at the same time, for those of you who are here for the first time, we need to give a little bit this background. So thank you. You can switch maybe to the second.
Second poll is on.
So again, this is for me to know if I am addressing a knowledgeable crowd, somebody who knows everything about that, or somebody who has never touched this technology. So this helped me in directing my explanations.
Okay, it's about 60%, somewhat knowledgeable.
Okay. Well, if you are like me, before studying this system, you were as knowledgeable as I am, because I have an electric vehicle and I plug in to charge it and then unplug it when it's charged. So that was about the extent of my knowledge about charging stations. You will see that there is lots to know about them. In fact, it's much more sophisticated than we might think. So perfect. If you think we're good to go, we will start with yes. So you can give me the camera so I can say hi to everybody live. So again, welcome everybody to this presentation on the electric vehicle charging station by Festo Didactic. So what you see behind me here is our training system to teach these topics. You might be impressed by the number of wires and everything, considering that a charging station is typically quite small. Everything fits in a box. But in fact, everything that I have behind me here is normally part of a charging station like that. So we will see, as I was saying, that it's more sophisticated than we might think. There's lots going on, communication messages flowing between the car and the charging station and things like that. So that's what we will be looking at together today. But first, we will start with a quick presentation of our company, Festo Didactic, and then we will dive into the topic itself. By the way, don't hesitate if you have any technical problems. Well, if you have technical problems connecting to hearing us or seeing us, you might try disconnecting and reconnect. Oftentimes it will fix the problem. And then if you have other questions, please, either technical problem or questions about the topic, don't hesitate to use the question section of the GoToWebinar interface to ask questions. Again, François Xavier is here to take all these questions and answer. So without further ado, let's see at what is the agenda for the next hour. So first, I will present the company, Festo Didactic. Then we will see how we design our training solutions here at Festo Didactic. And then we will dive in the topic itself. So first, looking at how the charging stations have evolved over the last few years. Then we will look at the interactions happening between the electric vehicle and the electric vehicle supply equipment that is the charging station. and then we will have a demo. Then we will look at each components that we find that can be found in a charging station. And finally, we will complete with the most advanced topics, which is RFID enabling of a charging station and how the charging stations can be integrated to the smart grid. And then again with a demo. The last part of the course is about teaching the technician troubleshooting skills, because again, this training system is to teach future technicians responsible to install, maintain these charging stations. So of course, we want them to be skilled at troubleshooting also. So there is a whole section of our manual dedicated to troubleshooting. And finally, a question period at the end. So quickly presenting Festo Didactic in 1925, Mr. Stoll in Esslingen in the neighborhood of Stuttgart in Germany founded Festo. Back then, Festo was a company providing woodworking tools, and that's how the company was born. In 1955, 30 years later, the pneumatic technology was starting to gain lots of appeal, and Festo decided to go in this direction, started producing themselves pneumatic cylinders and all that pneumatic technology for industrial customers. 10 years later, Festo realized that the technicians were lacking the skills in the new plants with all this new technology, so they needed to be trained. And Festo decided to found Festo Didactic, so the didactic branch that would teach the technicians, its own technicians, and any technicians in the industry, how to use these new technologies. Fast forward 50 years later, in 2014, Festo Didactic merged with LabVault, which was a company based in Canada and US, which had been developing training solutions and technology also for the last 60 years. And they merged together because their portfolio was compatible, and it was additive, let's say, because Festo was more dedicated to automation and fluidics, while LabVault was more concentrating, focused on electrical technology, electrical engineering. So merging the two portfolios made a really huge offering. And this is why today, now in 2020, Festo Didactic is one of the major provider of technical training solutions in the world. So here are the few, some of the main fields that we have training systems on. So factory automation, process automation, fluidics, building automation, environment and renewable energies, electronics, electric power, industrial maintenance, communication and radar, and HVAC and refrigeration. So today, of course, with the electric vehicle charging station, we will be more into the building automation part of and electric power also. It's kind of a hybrid between these two fields. Finally, a quick word about us here in Canada, Quebec. So we are currently broadcasting from Quebec City in Canada. The building you see there is the building we are broadcasting from. This is also the main building where all the equipment that is manufactured in Canada is manufactured. So this building also includes contains the plant itself where the systems are built. On the right, far right, you see the picture of all the training team here in Canada. So my two colleagues from left to right, Gonzalo, FX, François Xavier, who's with me, as I was telling you this morning, and myself, Christian, on the right. Finally, in the center, you see the picture of Mr. Mathieu Plourde, who is the product manager for this line of products in electric vehicle charging station and electric power. So how do we design our training solutions at Festo Didactic? Well, since we want our training systems to be as close as possible to the what is required in the laboratory to teach specific skills, we design, yeah, there's a small bug with a little glitch with the presentation of this slide here, sorry. So before designing the physical system, we always make sure that it will allow us to achieve the specific objectives, course objectives that we set ourselves to cover. So initially, we will talk with teachers, industry specialists, and our own specialists at Festo Didactic, Festo experts, to define what should be the objectives for such a training system. Then, based on that, we will ask our one technical writer, to write a series of exercises to achieve these objectives. And then, based on these exercises, we will come up with the equipment specifications, the learning system strategy, and then finally, we will build the hardware that allows us to achieve all these exercises, to perform all these exercises that have been pre-designed. And finally, the same technical writer will take back the equipment, his definition of exercises, will make sure that the hardware allows him or her to do all the exercises, and finally write the final version of the manual. So this way you are certain that what you get is a system that allows absolutely to achieve all the goals, and that the manual is perfectly in line with the system and the objectives. Any questions or comments up to now, FX?
Yes, we do have one question.
Yep.
I don't have the answer. I don't know about you. How many electric cars do we have in Europe at the moment?
You mean at that second? Oh, there's 2 more. Whoops, there is 5 more. Whoops. So it's increasing right now. It's increasing at an exponential rate. That's a really good question. I couldn't tell you, but what I know is that right now the sales of electrical vehicles is absolutely exploding everywhere, as well as much in North America as in Europe. But I wouldn't have a number. But in fact, I will show you a few graphs in a moment that will give you an idea of how fast this is increasing. And in fact, our graphs are dated. They date 2 years from. They're taken from 2 years data, and this has exploded even more so since then, because now we know that all car manufacturers have one or multiple electric vehicle models. So it's going big time in this direction.
All right, thank you, Christian.
Okay, so that's it. In fact, let's start with having a look at how electric vehicles, batteries, and charging stations have been evolving over the last few years. So here you see a really common scene now, which was something that might have looked futuristic or science fiction 10 years ago. You know, seeing a car plugged with electric cable. You know, 10 years ago we were only fueling our cars. But nowadays it's already become a common view, you know, to see these cars being plugged in while somebody goes take a coffee. So let's see why that's the case. Why is it evolving so fast? Well, first of all, you can see here on this graph from 2010 to 2017, I was telling you that my data was a bit dated. In fact, this data is taken directly from our manual. Okay, so of course, between the time a manual is finished writing and the system is commercialized, that explains why we have this 2-year shift. But everything you will see in the PowerPoint here is taken directly from our manuals. So you can see here how the price of the batteries, lithium-ion batteries, have evolved in euros per kilowatt hour over the last, well, not last, but over these 10 years. So we can see that it dropped. It was divided by 8, okay, the cost of these batteries. So of course, this made the electric cars much more affordable. At the same time, the cars started, because of that, the cars were able to implement larger and larger batteries with larger capacity in the cars. And we can see that in 2017 and 18, the EPA range of the cars, you know, went from 135 kilometers for the smallest to, as we know, Tesla 500 kilometers. And this has been beaten since. Now the new Tesla model can go up to 800 kilometers. And there are multiple cars now available that can provide 400 kilometers of range on a battery. Exponential growth. So on the left, you will see the evolution of rechargeable electric vehicle in use worldwide. So I don't have the data for Europe, but you can see that between 2010 and 2016, we went from basically 0 up to 2 million cars in use worldwide. This was in 2016. So I would say that now it's certainly 20 million or probably something like that, given the growth rate. And on the right, we have the global evolution of slow and fast charging stations. So at the same time, of course, the more cars on the road, the more charging stations are required. And we can see that more and more of these charging stations is of the fast type, which means that they are able to charge 80% of a battery between 10 minutes. So you just stop to get a coffee, a pee break, and you come out and your car is charged back to 80% of its capacity in 10 minutes with these fast charging stations. So the fact of not having the range on an electric car is becoming less and less of an argument against them. So a few pictures of different types of charging stations. So you can see on the left the typical charging station we will find in a private household, and on the right the commercial types, the really fast types. And in fact, on the right you can see that the same station provides two different types of charging. AC on the left, which is slow charging, well, between quotes, and on the right DC charging, which is the fast charging station. And here you have a clean picture of the charging system. So I will leave it here a little while just to show you the various modules that can be found there, because you will, as you saw on the system I have behind me, it's not as clean because I have lots of connections already done. So it's not as easy for me to present you with a clean faceplate. So I will switch back to the PowerPoint just to show you the various modules that are found in the system. So upper left, you can see, yes, here. So in the upper left, we have our three-phase power supply simply. Here, just beside it, is the charge controller. So this is the heart and the brain of the charging station, and that's the unit that we will be studying the most over the next few minutes. And then beside that is all the ancillary equipment required to connect safely a car to such an amount of electric power. So we have an energy meter here that will allow us to measure the amount of energy that was transferred to the car. Then we have an RCD to protect the user from ground fault currents. We have a circuit breaker that will protect against overload. And finally, we have our four-pole contactor that allows to close the circuit when the condition is met, to close the circuit between the electric supply and the electric vehicle. And then on the second row, we have exactly the same thing, but in multiples, because the same charging station will often be able to accommodate more than one vehicle and one charging style. So to be able to simulate that with our system, we needed to have these safety equipment duplicated so that we could have multiple outlets. So another energy meter here, this one is three-phase compared to this one, which was single-phase. Another RCD, another circuit breaker, and four-pole contactor, and then again, same thing here. Finally, we have a module of resistive loads that we will use to simulate, because we're not charging a real battery. We don't have a battery in the system to charge. We didn't want the user to have to unload, discharge and recharge the battery, between each class. So we are simulating different state of charge of the battery by applying a resistive load, and the system, this will control the amount of current that is transferred to the car in a much smoother way. The last module that I skipped is the RFID card reader that will allow us to enable or not the charging station if a proper RFID card is used, and this will be presented at the end. Okay, so here on the charge controller module, which I was telling you is the heart of the module, there are multiple plugs, as you can see, and controls. So we have a switch that will allow us to determine how the charge controller determines the amount of power that is exchanged with the electric car. So it's either done, either we simulate a specific rate at which the energy is transferred, or we read the specific rate from an energy meter. So we have both modes. So you have the option of using the energy meter or not. Then we have a bunch of contactors of contact here that will allow us to sense the status of the various safety device to know if the system is ready to be powered, to know if the car is ready to be charged or not. And then we have our two outlet plugs, one which is, as we will see, three-phase to charge the car with three-phase power at a fast speed. We don't have the fast DC charger here, but the fast three-phase charger we have. So this plug, or the simple Schulco plug, which is found in any European household to simulate, to emulate the kind of charging that you might have at your household if you don't have a fast charger. Then a few buttons to determine if we are in charge or not in charge, and a few switches I will come back to later on. We also provide you, and I can get back the camera for this effects. We also provide you with two simulated cars with the system. So of course, we would have liked to provide you with a real Tesla, and but this training system would have been maybe out of price. So instead, we provide you with these simulated cars. So we have this little Walther module here that allows us to simulate a car of different type with different plugs on the side. As you can see here, different plugs. So the Schulco or the Mennekes plug. And then on the front, we have controls to simulate different conditions of the car. So we can simulate, if we want to simulate the protective earth here, then we can indicate what is the ampacity of the cable that we use here. So the cable can the cable that is connected has different capacity in terms of current that it can carry, but here we can emulate different capacity, ampacity for these cables with simply these switches to see how the charging station react to being connected to a cable of one capacity or another. And finally, we have the switches here that can be used to indicate different states of the car, if the car is plugged, if it is ready to be charged, and if the battery requires a ventilation, if it is a ventilated battery or not. And finally, we can simulate two different types of charging, type 1 and type 2. So all of this plus a simple multimeter here that allows you to measure a few parameters from the circuit. Oh, and not the last but not the least, you have the CP plug here, which is the control pilot that we will be able to connect to look on the oscilloscope at the control signals that are exchanged between the charging station and the car. This comes, whoops. This comes with a cable that will allow us to connect to this. And finally, we have another car. This is to simulate a simple car. Well, in fact, it might be the same car, but a simpler way of charging the car, single phase in this case, instead of three phase. So this is more to emulate the kind of car, well, the kind of connections you have when you connect your car at home on your own in the typical wall outlet if you don't have a dedicated charging station. So this will be emulated with this here. Perfect. Where did I put that? Okay, whoops. That's weird. Okay, so what are the interactions happening between an electric vehicle and the supply equipment, so the charging station? So multiple things need to be covered. First of all, you must know that there are multiple connector types. Unfortunately, it's always the same thing around the world. It's really hard to come up with a universal standard. So there are different standards depending on where you are in the world in terms of connectors that are used to plug cars. In North America, it is the N Japan. Well, in Japan, they have CHAdeMO for type 4 for a specific type, but they also use the Yazaki, as the name suggests. It's a Japanese in origin. So North America and Japan use Yazaki. In Europe, it's Mennekes, except Italy, where they use the SCAME type of plug. And finally, for the DC charging, in Japan, they have their own standard, and then the rest of the world are using the combined charging system type 1 NDC or type 2 NDC, depending if you are in North America or Europe. So a few pictures. On the left is the Yazaki connector that we use here in North America. You can see that there are 5 connectors, while in the Europe Menekes plug, we have 7 connectors that we will look at in a moment. So the Menekes plug is the one that is provided with our charging system that I showed you here. The combo 2 DC plug combining the Menekes at the top and the 2 outlets for the DC plug below. So this is typically what we find on the Tesla car and all cars that support fast charging. And finally, the Schuko plug standard in Europe that you can use also to charge with low power your car if you don't have too high a battery capacity. The charging levels, so there are different types of charging levels, 1, 2, and 3. So household charging is level 1. It's single phase, and the power range is below 3.7 kilowatt. The level 2 is the slow public charging station, so it's not DC charging station. The power that can, so it's still single phase, and the power that can be transferred is between 3.7 and 22 kilowatts. And finally, the fast public charging station are typically DC for the fast ones. And as you can see, this can go as high as 200 kilowatts. So, I mean, this is really charging big time. Or 150 kilowatt, and this is what is used by Tesla and Chadimo for their fast charging station. For the 3-phase power fast charging station, 3-phase, the power is located between 22 and 43.5. So as you can see, the gain is not that great compared to the 200 kilowatt that you can get on a DC fast charging. The charging modes, 4 different types of charging modes. Again, domestic or type 2, it's the type of connectors, okay? So the supply side connector and the vehicle side connector. So either for mode 1, you will have a Schuko or other CEE socket on the supply side, and on the vehicle side, you will have a type 1 or 2 connector or permanently attached with the single phase voltage and currents that are allowed for single phase and 3-phase, and the amount of what kind of communication is happening between the charging station and the vehicle. So you can see that in the domestic mode 1 charging modes, there is no communication. So there is no communication between the car and the electric vehicle charging station. And that's why typically on the cable that you use for this type of charging at home, there is a controller embedded in the cable, and this is the one doing the controlling the amount of power exchange. And then the other types, I won't dive into too much details, but as you can see, the manual goes into all these details on the different types of charge modes. And finally, different charging times for 100 kilometers, depending on the mode that is used. So you can see that it can go from 6 to 8 hours if you are charging at home, you know, at your household for 100 kilometer, down to 10 minutes if you are charging at a 120 kilowatt fast charging station. And in fact, the 100 kilometer here depends on the capacity of the battery. The higher the capacity of the battery, the more kilometers you will get in the same time that you are plugged in. The Menekes cable here that you can see, the different connectors. So of course, it's 3-phase power. So we have one connector for each phase, line 1, 2, and 3. Then another connector for neutral and another for ground, protective earth. And finally, the 2 top connectors that you see, CP and PP. PP stands for proximity pilot. So through this, we indicate to the station if there is a car at the other end of the cable or not. So is there a car plugged in? And we will see that it is also through this proximity pilot that we indicate the ampacity of the cable that is connected. So what is the current carrying capacity of the cable that is connected? This is indicated by the proximity pilot connector. The communication pilot connector is the cable through which the communication signals will transit between the car and the charging station. So what are the different CP, so control pilot signals that happen, that travel between the car and the charging station. There are 6 of them, 6 different status that are indicated. Status A, the vehicle is disconnected. We will have a chance to see on the oscilloscope a bit later what it looks like. So a constant positive voltage at plus 12 volt. B, the vehicle is connected and ready to charge, but there is no charge happening at the moment. This is status B. Status C, the vehicle is charging. We will see that we have a PWM signal. Status D, the vehicle is charging, but it is a ventilated in a ventilated condition. Status E, no power. There is no power. It's an error status, kind of an error status. And F is error also with constant negative voltage at minus 12 volt. So here you can see, and we will see on the oscilloscope later on. But what you can see in status B and C here is that we have a PWM signal, and the amplitude, the positive amplitude of which varies depending if the vehicle is charging or just connected. So if the vehicle is just connected, the maximum value of our PWM is 9 volt, while if it is charging, the maximum amplitude is 6 volts. So this is how the charging station determines if we are charging or not. So before I dive in the exercise effects, do we have questions?
We don't currently have a question. We had a small issue with the blurriness of the screen of the PowerPoint, but I think it's better. On my side, it's crystal clear, but it might be different depending on where you're watching from.
Yes, yes, yes. So definitely, of course, we are always dependent on our local connections. We don't say that it doesn't happen that we have connection problems at our end also. But right now, what we see here seems to be clean. I mean, for my colleagues who are connected also through the internet, they see it clearly. So sorry about that. Hopefully this will get better. So here, the little procedure outline for the demo I want to give to show you here. So we'll see how to connect for mode 1 power circuit, how to connect for mode 3 power circuit, and we will see how the 2 types of charging is happening. So here on the screen, you see a schematic, again, taken directly from the manual, showing the student how to connect the various modules for the upcoming part of the exercise. So from the charge controller module, we will use only 2 lines out because this is single phase charging. So we will use line 1 and neutral, which will go to our single phase RCD ground fault protection device, then to the circuit breaker, then to 2 lines of the 4-pole contactor, and then to the charge controller itself, back to the charge controller, should I say, because we start from the charge controller and we come back to the charge controller to the plug of the charge controller. On the control or sensing connections side, the low power connections, we will connect again specific terminals of our charge controller, 15, 16, and 17, to the 4-pole contactors, RCD type B, and circuit breaker 16A. But as you can see here, we are not connected to the power plug of these devices, but to the control signal. So we are connected to the normally open or normally closed contacts on these devices that allow us to know what is their current status. So based on this signal, the charge controller will know if the circuit is safe to power the car or not. And this is a view of the web interface that allows us to communicate with the Walther communication, but I will come back to that later. So let's go to our module here. So yes, I'm sorry. Yes, thank you. So I will just sit over here. So I will quickly present to you the connections that are used here. You might see that there are many connections, but in fact, this is more than what is required for what I just shown you. Is just because I have kind of a later exercise that is plugged in here, where we have the 2 outlets of our charging station that are enabled. And so we will be able to charge, in this later exercise, we are able to charge 2 cars at the same time. In this first exercise where we introduce the students to the equipment, of course, we don't go as fast. Okay, so let's start with our single phase car that I just shown you. So here on the charge controller, we have two sections, one here for the three-phase charging and one for the single phase charging here, mode 1 charging. So starting from my charge controller, I send line 1 and neutral to the next module, which is the meter. By the way, I have inserted the meter. It's not required for the first exercise, but it will be required later on. So the meter, then from the meter, I go to the RCD. You can see again with my two connectors to the RCD, then my jumpers here to the circuit breaker, and finally to the 4-pole contactor here. And then from the outlet of my 4-pole contactor, I have line 1 and neutral because again, I am in single phase, going back to here, going back to the cables powering the plug to which the car will be plugged. So basically all of this here is inserted between the power coming from the grid, okay, and the plug to manage the safety aspect of the connection. Then coming back here. What about these small black cables here? Well, they are the ones, the sensing circuit that I was talking to you about. So leaving from terminals 15, 16, and 17, I am connected to the various normally open and normally closed contact on each of these devices here to know their current state. Perfect. On the three-phase side, we have exactly the same thing. So from here, I'm taking the three-phase output here. From this three-phase output, I'm going down here to a three-phase RCD device, a three-phase circuit breaker, my four-pole contactor, then going back to the plug here. So it's really simple once we understand all these connections. So let's see how this works in, yes, I will come back to my computer here. Thank you. And I will show you the web interface. Whoops. Here. Which I will have to reload, of course. There you go. So this is the web interface we have to the Walther electric vehicle simulator. Okay, and sorry, not to the electric vehicle simulator, but to the charging controller itself. So you can see that we have here on the charging outlets, the two charging outlets. So the three-phase charging outlet, which is one, the charging outlet 2, which is the one on the right. And right now it tells me, please connect vehicle on charging outlet 1, while on charging outlet 2, it tells me car ready to load. And this is because if we come back to the camera here, you will see that my three-phase car is not connected currently to the charging station, while my single-phase car is, my single-phase car, which is behind me here, is connected. So if I unplug this here, we will see that going back to the web interface. Yeah. This. Now it tells me charging outlet 1, please connect vehicle. In both cases, please connect vehicle. So it's constantly monitoring what is happening here. So now I will charge my two cars and you will see the status changing. Single phase, three phase. And now I have loading cable connected and car ready to load. So you can see here that the status is not the same depending if I use a type 1 charging, which is a charging outlet 2, or a more evolved. With the more evolved charging outlet 1, there is a communication protocol between the car and the charging station. So right now it just tells me the cable is connected, but the car has not told me yet that it is ready to be charged. While charging outlet 2, there is no communication. So as soon as it detects that a cable is connected, it says, okay, the car is ready to load. It is also in this interface that we will be able to indicate the property of our installation, okay? So this is where we will be able to set the energy meter, the value, read the value on the energy meter, We will be able to import or export configuration files, firmware update, okay, and here specify all the parameters for our specific setup. So the number of charging ports, the number of pulses per kilowatt hour that each of our energy meter is producing, the system mode, if RFID is installed or not, the different modes, charging modes available on port 1 and port 2, the maximum current capacity of each charging outlet. So all of this can be defined here. Okay, so now let's show what happened when we charge a car, the first car in single phase. Okay, so now my cable is connected. The car is ready to load. You can see that my status light here is blinking, telling me, okay, ready to start loading. So I just need to turn on here on, and my car starts loading already. Okay, I heard the contactor close here, and you can see with the LED. No, I don't think you can see it, but there is a LED lit here showing us that the 4-pole contactor is closed. Let me turn that. Yes, the LED there is lit, which means that the car is loading. So if I go back to my PowerPoint, you will see now that charging outlet 2 tells me that charging is in progress, and I could stop the charging from the interface here with the stop button, or I have the switch on the front face of my charging station also. We also see that currently we are using 3.60 kilowatt, and since we started charging, we have transferred 0.05 kilowatt hour in 15 minutes, so 50 seconds, sorry. So that's it for my charging outlet 2. Let's go now to the charging outlet 1, which will give us more to look at. So I will stop the charging here and go to my charging outlet 1. So thank you. Yes, let's do right. So first of all, on my charging vehicle, I indicate the ampacity of the cable with these switches. So this is a cable that can carry up to 32 amp, no problem. So I indicate 32 amp, but I could decrease that to 20 amp or 13 amp. And in fact, if I do so, you will see that the status here, which tells me ready, will change. Right now, the station tells me I am ready to start charging the car. But if I change my cable ampacity here to 20 amp, you see that now I get a fault because it tells me that the cable that is connected here, it doesn't have the capacity required to accept the charging current that this station is providing. So the station will refuse charging the car because it sees that the cable doesn't have the proper capacity. Of course, in this case, I am simulating a cable of a different capacity, ampacity with these switches. Typically, this is indicated by the resistance that is connected to the pilot, the proximity pilot, as I was telling you, that indicates the ampacity of the cable. So the cable has a fixed ampacity. So let's go back to 32 amp here. I get my ready switch. And now with these switches, I will indicate the status of the car. So first of all, the first switch will say to the system that the car is ready to be loaded. So this here just tells the system the car is connected. Okay, and in fact, I wanted to show you on the oscilloscope what this looks like. Okay, so right now you can see on my oscilloscope that I have a plus 12 volt signal, constant signal, and we saw from the different statuses that this indicates that a car is connected, and that's it. Okay, the car is connected, it's not ready to be loaded. Now with the first switch here, I will indicate to the charging station. So this is my car, don't forget, this is the car. So the car tells to the charging station, okay, I am ready to be charged with this here. And now you can see that the signal went from plus 12 volt to plus 9 volt to indicate that the car is ready to be charged. Then the next switch here will indicate that the first switch was indicated I am there, the car is present. The second switch is indicated I am I am ready to be charged. Okay, and so now I have the status light blinking here, so I can start the charging by simply flipping the switch, and you will see how the signal changes on the oscilloscope. So I do that here, and now the charging station is sending this signal to the car controller, telling it, okay, now you are charging, and we know that we are charging because our PWM is going from +6 volt, as I was telling you, to -12. And the pulse width is indicating to the car, here is the maximum current that you can draw from this charging station at this moment. Okay, so this is what the communication happening here is used for, because we will see in a moment when we integrate the technology in the power grid, the charging station need to be able to tell to the car, okay, sorry, I know that with your cable and your battery, you would be able to take 32 amp. Normally, I would be able to provide you with 32 amp. But right now, because of the demand on the grid, because of different conditions, I am not able to provide you more than 12 amp, okay, for example. So, and this will be indicated by the width of the pulses here. But right now, with these pulses, we are able to get the maximum power that the station can deliver. And we will see that in our web interface, that now charging outlet 1 is providing us with 22.26 kilowatt of power to our car. So this is the maximum power for the current configuration with 32 amp that can be provided by this station at 230 volt. Now, if we go to the details page here, we will see that we also get a graph indicating the current charging and the maximum current and maximum power provided. So you can see with the pink line here at the top that the maximum available is 24 kilowatt, and the average used right now is 22.8, as I was showing you. Okay, the blue line indicates when charging started, and if I stop it, you will see that a green line will appear here. So I stop the charging here. It takes a few seconds for the system to update because it does not monitor every second or every fraction of a second, but eventually I should see my green line appearing, as we see in the charging outlet 2 here. We have the green line which indicated at which time the charging stopped. So this is just to give you a global idea of the amount of power that has been consumed over many days, rather than giving you a to the moment precision. So that's it for what I wanted to show with this specific demo. Any questions?
Yes, we have a question regarding the languages available for the interface.
That's a good
English
question. I think so, yes. In the settings here, we can change English. I know that, yeah, that's what I feared. Deutsch and English. I'm sorry, this is a German product. Walther is a German company, and the only languages available are German and English for this interface. Sorry about that.
Okay, another question. Could we use the data acquisition module if we have it instead of the oscilloscope?
Yes, of course. For those of you who are familiar with our EMS training system, electric technology training system, if you have it at your at your school, of course you can use the data acquisition and the LVDAC. Yes. You can use our data acquisition with our LVDAC software to display these signals, that's for sure, as you can use this data acquisition and LVDAC software to measure any voltages or currents you might have in your school. Of course, since it is a system that is meant to be used with power circuits, if you have to measure only millivolts, probably you won't get the precision you need. But if anything within above 1 volt and above, you will be able to measure with this data acquisition, and this includes these signals.
One more question,
yes,
if you will.
Yes. Sorry.
So the charging current going in the cable is AC in this case.
The charging
Charging current.
Yes, yes, that's it. It is AC and it is converted to DC at the car. So the car is receiving AC power and converting it to DC to charge its battery.
Okay, and finally, I have the beginning of a question, but it's just the letter I. So I hope
We will wait for this.
Okay, so you can keep
Okay,
going.
perfect. Thank you. So we'll go back to my PowerPoint here. Okay, yes, so this indicates how to set up the system as I was telling you. Here are the connections for the three-phase circuit that I've shown you earlier on the system. So the different components, quickly, I will go through the different components of the charging station. Oh, you were not on the PowerPoint. Okay, sorry. So I just said that, yeah, after the demo here, we are showing in the manual, of course, how to set up the various parameters in the interface, how to connect the three-phase power circuit. So that's it. The charging station components. So quickly, the various components that are found in there, just to show you the amount of details that we go in these manual. First of all, the charge controller that is provided by Walther. So the unit that is embedded in our charge controller module, the big gray module, is this unit here that you see. So this is the charge controller embedded in there. It is a charge controller, as you can see, that has two independent outlets. So it can control, as is typical in many charging stations, two outlets at the same time independently. Then we have the 4-pole contactors that is embedded in our contactor module, the three-phase circuit breaker. So in the manual, we present each of these units, what they're used for quickly, so that the students who's for the first time exposed to these technologies know what it is. Here is a circuit diagram for the mode 3 case B circuit. So I won't go in details, but as you can see, we go in the manual in the details of how the connection is done between the electric vehicle, which is on the left here, EV, and the charging station on the right here, this electric vehicle supply equipment here. And in between is the cable itself. So as you can see in the cable here, as I was telling you, there is a resistor. So this is inside the cable. At each end of the cable, there is a resistor connected between the proximity pilot and the ground. Okay, so it is based on the value of this resistor that the charging station will know the ampacity of this cable, so the current carrying capacity of this cable. And on top of that, you have all the various resistors and controls here and switches that will be open and closed by the circuit, depending if we are ready to be charged, not ready to be charged, that will allow the communication happening between the two. And here you can see that we can switch between the plus 12 volt DC signal and which is standby to the pulse width modulation signal. And this is controlled by the CP controller, of course. Mode 3 charging cycle. So quickly, you can, of course. Mode 3 charging cycle. So quickly, you can, of course. Mode 3 charging cycle. So quickly, you can, of course. Mode 3 charging cycle. So quickly, you can, of course. Mode 3 charging cycle. So quickly, you can, of course. Mode 3 charging cycle. So quickly, you can, of course. Mode 3 charging cycle. So quickly, you can, of course. Mode 3 charging cycle. So quickly, you can, of course. Mode 3 charging cycle. So quickly, you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3, charging cycle, so quickly you can, of course. Mode 3 charging cycle, so quickly you can, of course. Mode 3 charging cycle, so quickly you can, of course. Mode 3 charging cycle, so quickly you can, of course. Mode 3 charging cycle, so quickly you can, of course. Mode 3 charging cycle, so quickly you can, of course. Mode 3 charging cycle, so quickly you can, of course. Mode 3 charging cycle, so quickly you can, of course. Mode 3 charging cycle, so quickly you can, of course. Mode 3 charging cycle, so quickly you can, of course. Mode 3 charging cycle, so quickly you can, of course. Mode 3 charging cycle, so quickly you can, of course. Mode 3 charging cycle, so quickly you can, of course.